This reaction here is known as the base catalyzed ester hydrolysis. We've already gone over the acid catalyzed hydrolysis. You might be wondering, well, why is there two? Well, I didn't create the concept of acids and bases, but what I will tell you is that the base one I personally prefer because this is an irreversible reaction, unlike the acid catalyzed ones. We're going to walk through the mechanism right now, so when you see this on your exam, you get it right, and so you know why it's different. So the first thing that happens here is we have our OH. This is OH minus. We're going to come in, we're going to attack that carbonyl. Just get all on up in there. We're going to kick these electrons up onto that oxygen. We're going to form this tetrahedral intermediate where this oxygen is negatively charged. My molecular geometry, my orbital geometry won't be perfect, so apologies, but deal with it. Now, instead of having a positively charged species like we do with the acid catalyzed, with the base catalyzed we have a negatively charged species. We have this alkoxide right here. What's going to happen is we're going to bring these electrons back down to form our carbonyl again, and we're going to kick off what was our alcohol portion, forming an alkoxide. We are now left with our carboxylic acid. Ta-da! The end. Just kidding, not the end. Well, yes, we have formed our carboxylic acid. It's a little bit misleading because while technically this does form the acid, in reality there's one more workup step to this because we're still hanging around in a basic solution. We are gonna, I forgot one there too. We're gonna come and steal that proton and we're gonna deprotonate our carboxylic acid we just made. And we're gonna kind of run out of space here, I think. We're gonna make this carboxylate ion. Now, this is what makes this irreversible because this carboxylate ion, is very stable. It can participate in resonance. We can go here, kick this up. Now, we have this, where this is positively charged. And so that positive charge, negatively charged. This negative charge is shared throughout there, making this much more stable. So we don't really have to worry about anything going on with that. And even say we could, say that our alkoxide comes in and attacks that again, we'd have to push these electrons, like say our alkoxide we just made, attacks this. We'd have to push these electrons up here, which makes a dication, which is stupid unstable. So in reality, what you do is you have your carboxylate ion, and then you just do acidic workup, and you get your carboxylic acid back, and you'd also get your original alcohol back.